I'm going to talk a little bit about digital identity and blockchains. This is can be a very deep subject. I've gone to many multi-day workshops talking about exactly this topic and going through it in great detail. So this is going to be a compression of a lot of information into a very short period of time. So, just a little bit of background on myself just to help with this. My background has all been in building startups. I've been doing that since 1994, primarily on the technology side. And, the last 4 startups that I ran technology for all went public at over $1 billion valuations on the internet side. And I moved over to Bitcoin and blockchain just about 3 years ago. So, our background of us and our team is really in building and scaling startups, working on security, and actually also crossing over into the regulatory and policy areas. So, blockchain-based identity is actually an unbelievably exciting topic. If you think about the way that online identity has worked up until now, basically someone else has owned your identity. Right? Facebook owns your identity and they share it with who they want to, sometimes with your permission. Google owns your identity and they share it with who they want to, sometimes with your permission. And there's many other providers out there that are doing exactly the same thing. And one of the really strong promises of blockchain-based identity, or as it's coming to be known, self-sovereign identity, is it puts the user back in control of their own identity. It's stored inside of a storage locker that they own and they can control. And people aren't able to access that identity data without their permission or without their clearance. So think of that as very different than the way the internet works today, where all of this information is getting shared behind the scenes without you knowing about it. So what's the architecture look like for some of these solutions that are being built and where they're going? As and as some of the things people have talked about before, you actually probably don't ever want to write identity data itself to the blockchain, right? And the reason for that is when you're writing identity data to the blockchain, the only thing that is protecting that data is encryption. And as we all know, there has never yet, and I don't know that anyone knows of one coming, a form of encryption that doesn't eventually obsolete. Right? And obsoletes in much shorter than a person's lifetime. And if you wrote that data to a blockchain, which never went away and is shared with everybody, you know that eventually that data is going to be revealed to anyone who wants to look at it, and that your privacy and personal information is going to be broken. It's going to be available to others. And so the way that people have solved this is using the blockchain for what it's best for, being a directory that's a pointer to other areas. And then the individual actually has a storage locker that their identity is kept in, and then an agent that sits in front of that storage locker that they control that provides access or provides permission for that data. So imagine if you wanted to share identity information with someone, the first thing that you would give them is your blockchain identifier, right? And then they would go to that identifier on the blockchain and it would have a pointer to where your identity locker was and where your information was stored. This solution is really exciting. It's really promising. It promises to have a lot of scale availability, help with privacy, help with user control of data, and make it very difficult for your personal information or personal data to be, for lack of a better term, weaponized against you. Because people won't be able to access that data on a mass scale. They won't be able to see it without looking at it, without you giving them permission to look at it. The downside is it's not ready yet. So this is a technology that's still being developed and built. I would say it's very much in the science phase and not yet in what I would call the engineering phase when projects are actually live. So I'm going to go through a couple of the companies that are kind of working in the space and what they're doing and where they're at. One of the most exciting ones is a company called Blockstack. They're based out of the New York City area, run by a couple of Princeton PhD students, or a PhD, I think one of them graduated now, Munib, their CTO. They are using a blockchain directory at root. Today, it's based on the Bitcoin blockchain, although they've also got some things working on Ethereum. And sort of the phase that they're at right now is they have a lot of the work done, but the idea behind the private identity locker hasn't really been worked out yet. So a lot of the blockchain work has been completed, but that private identity locker and the agents around it haven't yet been done. I suspect that these guys will be getting real-world solutions in place in the next couple years, and I'm excited to see what's happened here. They're also focusing very heavily on decentralized web. And what decentralized web is actually taking a lot of the functions that ICANN provides today for the internet, so things like handing out IP addresses, managing domain names at the root, and all those other things, and taking the administration and management of that away from people and moving it onto a blockchain, which is pretty exciting from a censorship perspective. One of the next ones out there that's getting some traction is Uport from Consensus. Uport is Ethereum-based. It's smart contract-based. They've actually released a product into production and have several customers that they're working on getting into that product. However, because they're actually storing the private identity information on the blockchain, and today they're actually storing it even unencrypted on the blockchain, it's kind of a privacy disaster. So there's a little bit of work that needs to get done there to really clean it up and get it to be something that's kind of ready for everybody. Microsoft is betting big in the space, and they're actually working with both Consensus and with Blockstack, and a little bit with us as well, to be honest. It's based on the Blockstack code at the core, from what I understand. It's launching in stages. The first stage was supposed to be out by the end of the year, so I suspect it's going to be out shortly. I haven't seen an announcement on that yet. And their detailed architecture isn't yet public, and so it's difficult to say for sure what some of the strengths and weaknesses are of the system or where it's going. But I suspect, frankly, given their budget, their market reach into large corporations and other things, this is going to be a platform that ends up getting some traction fairly quickly once it gets live. I'm aware of at least one very large enterprise company that's looking at them very closely. And then a little bit about what we're doing quickly, which is not blockchain-based identity. These were all solutions of identity on the blockchain, which we think is very important and very exciting, but as we said, kind of not yet ready for prime time yet. But what we found was when you're dealing with Bitcoin, or you're dealing with Zcash, or you're dealing with other forms of financial instruments, not every company, but a large number of companies are actually going to have regulatory requirements around that, right? If you're a bank, you need to know who your customer is. You also need to know who your customer's counterparty is, because nobody wants their customers sending money to terrorists, right? So you have to know who your customer is sending money to. And so this is actually a place where blockchain pushes a need for digital identity online. And so ours, as I said, is not today blockchain-based because we were concerned about some of the things that are still going on there. All the identity is stored privately in a user storage locker. Actually, in the case of the identity pieces that I'm using today, my identity data sits on my phone over there, and I can approve or disapprove whenever anybody wants to take a look at it. The user's in control of who has access, and we've got a few pilots live with a number of large companies today. So let me maybe walk you through the architecture that we did build really quickly, because I think it ties into where some of the self-sovereign identity stuff is going, although using more traditional technologies. So, the certificates that we're using are recognized as legal digital identity by the US government and other governments. It's a form of digital identity that's been around for a little more than 20 years now, and as a result of it, there's actually a legal basis behind the identity we're using, as well as even treaties between countries saying that this is legally valid identity. The way that the proposal works, we actually built on an existing Bitcoin standard. Originally it was BIP 70. We announced we built an extension to it, BIP 75. And basically the way that the flow works is in advance of a transaction. And this could be a financial transaction. This could be a transaction for a medical blockchain where someone's requesting record information. It could really be anything. You know, if Bob wants to connect to Alice, what will first happen is off-chain, Bob will make a connection to Alice and say, hey, Alice, I want to transact with you. And he'll sign that certificate, or he'll sign that with his certificate. Alice will then be able, on her side, to say, yep, Bob is somebody I want to do business with. Her service provider can say, yep, Bob isn't a terrorist. And so at that point, Alice responds with an invoice and signs that with her certificate. And that invoice contains the user's payment address and payment data. So Bob can't send money to Alice before he gets that address, right? It protects Alice from getting funds that she shouldn't be. At that point, Alice sends back her payment details to Bob, again off-chain, signs that with her certificate. Bob now knows that Alice is who he wants to transact with, and does the final settlement to the blockchain. And a receipt goes back to Bob at the end to be able to kind of tie everything together. And that's it. So, questions?
Let's give a big round of applause.
So this is like KYC on blockchain. Can this be applied to KYC? Like for example, banks, financial entities or corporates starting to do business with each other?
That's a primary use case. It is actually one of the reasons we designed it. So, you know, for me, when I came into Bitcoin and other blockchains, what I said is I wanted to figure out where there were barriers to commercialization or mass market adoption. And one of those barriers was I didn't think that this was ever going to get huge until large companies could use it, and that large companies could provide services to their customers.
But the problem is that right now there's a lot of doing in Europe that there's no digital notarized documents. So for example, all this lives in the digital world, but for regulators, you need to actually bring them a stack of papers to say, Bob did a KYC analysis. You cannot turn this stack of paper right now in Europe. In America, you can turn it legally into a digital stack of paper, but in Europe, you still can't. And this is sort of like the question of like, have you thought about actually solving how to connect this to the Justinian justice system that was built 1,500 years ago? Because that is, technologically, this can be solved in many other ways, but it's really like so that the judge understands that this identity that Alice given to Bob is actually legally binding. That I think is the question.
Yeah, so I am not super familiar with the laws of Eastern Europe. I have to be completely honest with you.
I'm talking about European Union.
So inside of the EU, the certificates that we're using are legal forms of digital valid identity. So anything that you sign with our certificate is exactly the same as if you signed it with a pen and paper from a legal perspective. And judges know that. And there's actually treaties between the US and other countries confirming that that's the case.
Okay. At least in Germany it's solved.
Really? But the papers, like for example, I'm dealing with Reuters like OrgID and Swift KYC, they still require stacks of paper. Like Reuters, you cannot send them like digital copies and then you do KYC with JP Morgan or somebody else. They still want actually physical papers like for you to send. So this is, in Europe, you cannot turn, there's no concept of e-notary, where you can take a digital, a paper document and then turn it into a digital document, which a notary is subset. Like a certified true copy for a bank is a piece of paper with a stamp and a signature. You cannot bring a certified true copy in a digital form.
I'm not sure about the commercial usage. I'm not sure about the commercial usage. I mean, user towards companies. But for sure it is solved for the government part. So you can sign as an individual in Germany with your private key, which you get together with your personal identification. You can sign it, and it will be accepted by the government. You don't need to bring any papers no longer. That's solved.
Okay, and we have one more question here.
Hi. I'm wondering if you see any common threads or themes or trends for how people are dealing with verification and recovery of certificates or credentials.
Yeah, I mean, so in our case, we're actually, built on top because of the legal basis behind it. We actually built on top of the CA model, right? And so as a result, there's a pretty robust revocation process around that.
So you just kind of inherit the revocation recovery process from the
Yeah, from X509 and CAs and that kind of stuff.
Okay, one quick
Right,
other
and
question.
so with that's actually one of the things that I think is still unsolved on the blockchain side, right? Because revocation is a place where centralization makes it easier.
I actually disagree with that, because if I publish a revocation to a server, and even if you know about that server, if your adversary does too, they can DOS it. Whereas if I publish a revocation on a blockchain, you can't DOS it.
Yeah, but I think if you're only, one of the things the CA model has is there's one person that's attesting, right? The CA is. And one of the challenges in the blockchain model around revocation is that you may have dozens or hundreds of people that are making attestations, and going and cleaning up and getting the revocations around all of those could be challenging, right? And then you also have issues when the initial credential is issued and the company behind it, or whatever it was behind it that gave that credential, goes away. There's not a clear process for cleaning that up.
Sure. And one last final question.
Yeah.
Are you guys, or is anyone focused, any of these projects focus on composability? Like, identifying a company having credentials for, or an institution?
Yeah. Yeah, we actually validate companies and corporations and organizations, or we'll validate things that are, for example, is this person a medical doctor? Do they work at this company? So we can get pretty detailed in terms of the different things that we're looking at and able to do attestations around, depending on the use case that needs to be solved.
Blockstack and Uport?
Blockstack and Uport aren't doing the attestations themselves. They're building a software platform for other people to do it on. So if they find other people to do those attestations, then yes. But today, they don't have, from what I've seen, any commercial attestation providers on their platforms, so it's hard to say what the eventual look will be. I'm happy to follow up a little later, though. Yeah.
Okay, yes, we are all happy to follow.